Hello everyone, this is Vega to you, and today I'm going to show you how to sketch graphs of the derivative. So usually when you've got a function, you've got y equals x cubed minus 2x squared, whatever, and you can easily find dy dx. The derivative is just a simple, 3x squared minus 2. But sometimes you can't do this because you've just got a graph. So, for example, if you have a cubic function, I'm going to show you how to sketch this, the derivative of this. So, with any sort of function, so say we've got these two cubics. So this cubic here, you can see your stationary points of inflection. So that's at -1, and that's at 5. These stationary points of inflection on the derivative will be the x-intercepts for the graph of the derivative. So, here's an x-intercept and here's an x-intercept. Now, the graph will always be 1 power lower, so this graph here will be the graph of a parabola. So, you know that between points 1 and 5, the graph has a decreasing gradient, and anything outside of that, it's increasing. So when that's a sort of negative gradient, everything else it's a positive. So we know that between 1 and 5, we've got the parabola going down. It's going from up here down between these points, undefined, and up there. So that's the really simple way of doing this. So again, with this on the other way up, so say this is -3, and this is 3. Well, with this cubic, we know that all up this side here, up here in the top corner, that is all negative, and so that's all the negative gradient up to 3, and between up to -3, and between -3 and 3, it's a positive gradient if we have this other stationary point of inflection where the gradient's obviously 0. So yeah, we can work on that and say that between the -3 and 3, we know that's the only bit where there's a positive gradient. So we can draw a parabola facing a bit up like that. Now, because there's no information on the graph, you obviously don't know where this is, and it's why you use it. Otherwise, you might do a regression, simultaneous equation, whatever, and find out the function. But this is so you know your turning point for the quadratic. So yeah, when you're doing a cubic, this is the simple way of doing the function. Now, if we are trying to do the regression for parabolas, if we're trying to sketch the derivative of function of parabolas, it's again just 1 power below, so it's a line. So we know that the turning point, as the gradient's 0 there, the line of the derivative will pass through the same point, so it's -2. And so we know that as before can't speak. We know that prior to -2, it's all a negative gradient, and after, it's all a positive gradient. So you simply can draw a line, and you can tell, and that's the gradient function at any point of this. So wherever that is, you can tell the gradient. So again, with this one here, we know that this point, say 1, this stationary point of inflection where the gradient is 0, and we know that we can just draw a line straight down here, because up until that 1, the gradient's all positive, and after it's all negative. So yeah, that's a really simple way of doing it. Now, if you have defined the derivative function of a linear equation, then you do need to at least, well, it's useful if you kind of need to know the function, but say you don't, you just need to know which way it's going. So you know this line here has an entirely negative gradient, so it means that the gradient will be a horizontal line in the negative of here for any value. Now, if we have a linear equation, obviously that's positive, like this. It's a positive gradient. Then we also know that we'll have a horizontal line indicating the gradient there. So it'll be above where x equals 0, this line here. So yeah, that's a really simple way of sketching the gradient of any sort of the sketching graphs of the derivative. Thank you for watching. Hope you enjoyed and find this helpful. This has been Vaga to you, and goodbye.